New findings regarding the extinction of dinosaurs. The asteroid wasn't the main culprit. What killed the dinosaurs? It is believed to have been caused by a space rock that hit Earth about 66 million years ago. However, there have long been suggestions that an asteroid impact was not the main culprit of this mass extinction. New research suggests that climate change triggered by numerous volcanic eruptions may have set the stage for the extinction of the dinosaurs, challenging the traditional narrative that the meteorite itself dealt the final blow to these gigantic creatures. A new analysis by an international team of scientists shows that even before the asteroid impact, volcanic activity on Earth was strong enough to cause significant climate change. Scientists suggest that even if there had been no space rock impact, the fate of the dinosaurs was probably sealed. The results and description of the research were published in the journal, Science Advances. The new analysis is based on research on the so-called Deccan gangways. These are large plains formed by solidified lava, forming the Deccan Plateau in India. They were created at the end of the Cretaceous period, about 66 million years ago, in what is now India, which was then a separate continent. Lava flows currently cover an area of approximately 500,000 square meters. Kilometer 2, although their original range was probably much larger. When examining rocks collected from the Deccan gangways, scientists used a new technique they had developed to measure sulfur concentration. In the laboratory, they estimated how much sulfur and fluorine were released into the atmosphere by massive volcanic eruptions that took place over 200,000 years. Years before the extinction of the dinosaurs. They found that violent volcanic eruptions may have played a key role in cooling the climate around 65 million years ago. The release of sulfur may have caused a global drop in temperatures around the world, a phenomenon known as volcanic winter. Our research shows that climatic conditions were almost certainly unstable, with recurring volcanic winters that may have lasted for decades before the dinosaurs became extinct. This instability made life difficult for all plants and animals and set the stage for the extinction of the dinosaurs. In this way, our work helps explain this significant extinction, said Professor Don Baker from McGill University in Canada. Discovering clues in ancient rock samples was no small feat. In fact, a new method developed at McGill University has helped decipher the history made by volcanic activity. The technique for estimating sulfur and fluorine release is a bit like cooking pasta. You can imagine making pasta at home. Boil water, add salt and then pasta. Some of the salt from the water ends up in the pasta, but not much of it, Baker explains. Similarly, some elements become trapped in minerals as they cool after a volcanic eruption. Just as the salt concentration in the water in which pasta was cooked can be calculated by analyzing the salt content of the pasta itself. The new technique allowed scientists to measure the sulfur and fluorine content of rock samples. Thanks to this information, scientists were able to calculate the amount of gases released during massive volcanic eruptions before the extinction of the dinosaurs. The models developed in this way indicated that persistent sulfur emissions from the Deccan gangways were enough to significantly change the global climate. This volcanic region alone released a staggering amount of 1 million cubic kilometers of molten rock. Volcanism in the Deccan Traps area set the stage for a global biotic crisis by repeatedly worsening environmental conditions, causing recurring short volcanic winters, the team concluded in the publication. As a result, Global temperatures may have dropped periodically by as much as 10 degrees Celsius over thousands of years. This, according to researchers, led to a global decline in the number of non-avian dinosaur species, even before the asteroid impact.